So we're talking about polar coordinates, and we'll be talking about coordinates of points, and we'll also be talking about converting between rectangular and polar coordinates, as well as converting between rectangular and polar equations. We won't be graphing so much in this. This is more theoretical. A couple of things you're going to need to know in order for this to work is be thinking about reference triangles. Those are going to come up again. That shouldn't be a big surprise, though. We've had that like in every single thing we've done this semester, right? So be thinking about reference triangles, positive and negative values in the different coordinates. You're going to want to be thinking about coterminal angles. Y'all remember coterminal angles? Can you give me a coterminal angle for, say, I don't know, 90 degrees? Give me a 90 degrees. A coterminal angle is 450 because 90 plus 360 is 450. What's another coterminal angle for 90 degrees and 450 degrees? Negative 270 would be a coterminal angle because 90 minus 360 is negative 270. Completing the square pops up in this stuff. Do you guys remember how to do that from first semester? We got a little opportunity to rehash that. The simpler form of completing the square. It's like an old friend. Just popped around to have a cup of tea with you. Well, then you would want to see them if they owe you money, right? All right. Are we ready? Let's do this. So polar coordinates. So rectangular coordinates, we're used to this. We give coordinates in X and Y. And X is how far it is from the Y, or from the origin in the X direction. Y is how far it is from the origin in the Y direction. Polar coordinates, instead of X and Y, we're going to give R and theta. So with X and Y, with rectangular coordinates, it's kind of like, how far do I need to walk in the X direction? And then how far do I need to walk in the Y direction to get to that point? With R and theta, it's kind of like, what direction do I need to face? That's theta. So give me the angle that I need to face towards. And then how far do I walk out from the origin to get there? That would be R. So if I asked you to give me coordinates of this point in rectangular, that's like a 6th grade math problem, right? You can all do that. You could all say, well, it's 4 units out from the origin in the X direction and 8 units up from the origin in the Y direction. So 4, 8. But we're going to switch over to polar. So if I ask you to give me the coordinates of this in polar, we need to figure out 2 things. We need to figure out what is the radius from the origin. So the distance from the origin, that would be our R. And then what is the angle that we would need to face that point if we were standing at the origin in standard position, which means we're starting at the positive x-axis, rotating counterclockwise. And we actually have a lot of the tools that we need for that already. So I challenge you right now, before I even give you like the new formulas and everything, I've got a good feeling that you guys would be able to find me those coordinates in polar just based off of what we know already. Could you take a moment and do that? Think about how this relates to things like, I don't know, vectors. How does this relate to vectors? What would we call R if we were talking about this as a vector? That would be like the magnitude. Don't you guys know how to find magnitude if you have an X and a Y component? See if you can apply that. And theta would be the direction of the vector. This is really strongly related to vectors. See if you can find me an angle and a magnitude there. Take a moment, see what you can do. So if you need a hint, go ahead and peek at the board here. I haven't used anything new. This is all just straight from our vector stuff. And if you're having a hard time remembering how to find the magnitude and angle of a vector, that's something we definitely want to go back and review before our test. That was a huge part of 6.1, 6.2. But root 80 or 4 root 5 if we're simplifying, and 63.4 degrees roughly is what we should be coming up with. Bless you. Bless you. So I'm going to give you some equations for how to deal with this in a moment. They're all going to look very familiar to you. Before we go on though, any questions about what I did there? And if not, I have some more questions for you. I'm going to rewrite this down here. 4 root 5 comma 63.4 degrees. That is one way that we could name that point, but it's not the only way that we could name that point. Think about coterminal angles and see if you can come up with another name for that same point. I'll give you a hint. It's still going to have a 4 root 5 in it, but the angle is going to look a little bit different. We could do it in radian. Let's stick with degrees though, just to keep things simple. We know that facing in the direction of 63.4, there's other angles that we could turn and still end up facing that same direction. Give me one other angle that you could face and be facing the exact same direction as somebody facing 63.4. $403.4, 423.4. 423.4. How are we getting that 423.4? We could just do plus 360, right? Could you give me another one that would work? Okay, hang on, let me catch up to you here. I'm having trouble writing radicals for some reason. 4 root 5, and can you say that again? Negative 296.6 degrees. So you're taking your 63.4 and doing what? Doing minus 360. Can we add and subtract some more versions of 360 to get it? Yeah, for sure. All right, now there's another one. There's another way we could change this. And I'm curious if anybody can find me the right angle for this. And there's more than one. What if I used for my R negative 4 root 5? You want to take a guess? 243.4 243.4 is one correct answer. $243.4. Oh, I'm hearing some light bulbs turn on. So this right here is 63.4, right? 243.4 would be about right there. That's 180 degrees off of that. And here's my negative. All right, this is kind of weird. A lot of times people don't like this about polar coordinates, but you can give a negative value for r. Now that doesn't happen with vectors. We never ended up with a negative magnitude for a vector because a magnitude can't be negative. But here's one of the differences with polar coordinates is you can't have a negative value for your r coordinate. So I want you to think about it this way. When I give you an angle and an r value, really I'm telling you which direction to face and how far to walk, right? So imagine someone standing at the origin and I tell them to face towards 63.4. So they're facing in this direction, but they're still at the origin. And I tell them to walk 4√5, which is about, what does that end up being? About 4√5. Someone give me a square root of 80 is about, oops, can't punch buttons. It's like 8.99-ish, all right? So you're standing here, you're facing this direction, you walk 8.9 steps forward. Okay, that gets you to this point right here. What if I asked somebody else to stand at the origin and I had them face exactly opposite, so 180 degrees off of that, that's at this angle right here. They're still standing at the origin, and I tell them to walk negative 4√5. They're not going to walk forward 8.9. Which direction are they going to walk? They're going to walk backwards 8.9, and they're going to end up getting to the same spot. So if they're facing this direction and their r is negative, they would end up getting to this spot. Does that make sense? So when you see some negative values of r, you need to keep in mind that you're actually going to be facing the wrong direction, the exact wrong direction, but you're walking backwards instead of walking forwards. Get the idea? All right. So here's the conversion equations we'll be using. And these should look familiar with some small changes. So r cosine theta and r sine theta, that came up way back in vectors. That's what you guys use to solve all these wonderful problems that are hanging up around the room here. R squared equals x squared plus y squared. That's kind of the general format. If I solve that for r, now we have to keep in mind that it could be positive or negative. So r is permitted to be positive or negative when we're talking polar coordinates. And then we got tan theta equals y over x. And the big hint that I have for you is when you're talking about theta, make sure you're really careful about what quadrant you're in. So a lot of times you'll solve for theta, but if you're using an inverse tangent to solve, you may not be finding theta, you may be finding a reference angle rather than theta. So you may need to do a little bit more work to find theta. Add or subtract from either 180 or 360. We'll look at some examples of that in a minute. Anybody need a moment to get those down? I see a couple people still writing. I'm going to give you another minute here. We're going to do some examples. So we'll do 2 examples each, converting from rectangular to polar and then polar to rectangular. And then we'll talk about converting equations, which is everybody's favorite. Let's start with points though. So polar to rectangular, here we go. So I'm giving you a polar coordinate. I can tell that this is a polar coordinate even without the instructions because of that degree symbol. So my assumption is that r is 10 and theta is negative 210. And all we need to do is come up with x and y coordinates. So we have some nice equations for this. You know what would be make this a little bit easier in my mind is if we 210 is not a very negative 210 is not a very friendly angle. Thank you. I might try and come up with a coterminal angle that's like something that I'm more familiar with. So we could add 360 to that. So what could we use instead of 210 if we wanted to, or negative 210? That's 150, right? So I'm going to use 150 instead because 10 comma 150 would be the same exact point. So this should be pretty simple. X is equal to, well, it's r cosine theta, right? That's what we've been doing even when we were doing vectors. So my r is 10, my cosine, and I could do negative 210 or 150. I'm going 150 because I have those memorized. And y would be equal to r sine theta. Again, I'm using the version that's 150 because I have those memorized. So do you remember the cosine of 150? See if you can do this. Let's practice for this memorization quiz that's coming up on Wednesday. Cosine 150. What's the reference angle for 150? What's the reference angle for 150? Can you picture that in your mind? Here's my unit circle. Here's 180. How far is 150 away from that? So my reference angle is 30. So what's the cosine of 30? Because the cosine of 30 is going to be the same as the cosine of 150, except it might be negative. In fact, the cosine of 150 is definitely negative, isn't it? What's the cosine of 30? Do you remember? Cosine of 30 is root 3 over 2. Cosine of 30 is root 3 over 2. So it would be negative root 3 over 2 because cosine is definitely negative in that quadrant. So 10 times negative root 3 over 2 is negative 10 root 3 over 2. Or we could simplify that. That's negative 5 root 3. So my x coordinate's negative 5 root 3. Folks, I'm going to provide you with a unit circle on our next test. You don't have to have these memorized. Okay, but I do need you to be able to come up with exact answers. How about sine of 150? Well, we already know our reference angle is 30. The sine of 30 is a half. Now, a sine positive or negative in that quadrant? It's positive. So 10 times positive a half. So that's just 5. So negative 5 root 3 comma 5 would be our value. Cool. And again, if you didn't have that memorized, don't forget, and hopefully you all haven't thrown away your super fun identity sheet, right? If you didn't have that memorized, remember you've got that negative root 3 over 2 and that 1/2 right here on your sheet. Okay, I'm going to try and do this one from memory too. So x and y, pretty easy, right? They give us r and theta, so x is just r cosine theta, and y is just r sine theta. So I can do this in my head. In my head, I think about a unit circle and I think about where 7 pi over 4 is. 7 pi over 4 is right here. And its reference angle is what? in degrees. Anything over 4 is going to have a reference angle of 45 degrees. So it's going to have a 45-degree reference angle. So 5 times something, 5 times something. Tell me about sine and cosine in this quadrant. Is cosine positive or negative? Cosine's positive and sine is negative. All right. Well, what's the cosine of 45? Root 2 over 2, and the cosine and the sine of 45 is, well, also root 2 over 2. That's nice. So we're going to end up with positive 5 root 2 over 2 and negative 5 root 2 over 2. And remember, if you didn't remember all that stuff, that's okay, because you've got cosine 7 pi over 4 right here on your sheet. Okay, you need to remember how to read it. But here's 7 pi over 4, and the cosine of 7 pi over 4 is positive root 2 over 2. And the sine of 7 pi over 4 is negative root 2 over 2. It's all right on your sheet there. So 5 root 2 over 2 and negative 5 root 2 over 2. Okay, questions on those ones? Those ones in my mind are the easy ones, unless you're trying to do it by memory. Then it's a little bit trickier because, you know, there's a lot to remember. By the way, if they'd given us an angle that we weren't familiar with, something that was not on our sheet, we just have, we could try use addition and subtraction angles. I'd say for this, punch it in your calculator and get a decimal approximation. So if the angle that they given us here had been like 212 degrees instead, I would just be typing 10 times negative 212 degrees, or 10 times the cosine of negative 212 degrees, and just coming up with a decimal approximation. Okay. So if they give you an angle that we don't know, you don't have to give me an exact answer. On the test, I will say, I'll give instructions that say, give exact answers whenever possible, around to 2 decimal places otherwise. So whenever possible means if it is an angle that's on this sheet, then I want exact angles, or I want exact answers. Good. All right. Rectangular to polar. So there's no way to know this for sure other than the instructions tell us to go from rectangular to polar. So I'm giving you an X, I'm giving you a Y. You are to come up with an R and a theta. Keep in mind there's more than one correct answer when you're going into polar. So let's figure this out. So R should be the easy one. We could think of this as a vector and just find the magnitude, and that would give us our R value. So R is the square root of x squared plus y squared. We've got values for x squared and y squared. X squared would be 4, y squared would be 1. So we're looking at root 5 for R. Theta is a little bit trickier. I encourage you when you find theta to draw a reference triangle. That's how we did it way back in 6.1. That's how we did it way back in chapter 4 and chapter 5 also. So to find theta, I would draw a reference triangle. I would just make a rough sketch of where that would be. Negative 2 comma 1 is in this quadrant someplace. It's 2 units to the left and 1 unit up. The y coordinate's positive. In part B, yes, it will be in the third quadrant. So what I'm going to do is I'm going to solve for this angle right here. But that's not theta. Keep in mind that's not theta, right? That's the reference angle. Theta is this angle here. It's going to be bigger than 90, smaller than 180. But I'll start by solving for this angle here. And that angle there, we can use an inverse tangent to find it. Inverse tangent of what over what? So I would just go, and I'm just going to go 1 over 2. Because I've already put it in the right quadrant, I'll be able to deal with my signs and everything there. The problem with using inverse tangent with negatives is this. Remember that inverse tangent is only ever going to give us an angle between -90 and +90. So it's never going to give us an angle that's in this quadrant. So I'm just going to think of this as a triangle, find an acute angle that is less than 90. And the inverse tangent's capable of giving me that, and then use that to figure out what this is. I'll just do 180, whatever my answer is, to find that. Okay, so when I'm doing inverse tangent of 1 over 2, I'm looking at this angle here. Opposite over adjacent would be 1 over 2. I punch that in my calculator, making sure I'm in degree mode. Gives me about 26.6 degrees. But that's my reference angle, that's not theta. We can use it to find theta. Theta would be 180 minus that. Which is about 153.4 degrees. Could you all do something similar for me for part B? The R part should be relatively straightforward. You know what x squared is, you know what y squared is. To find theta, draw me a reference triangle. And I'm hopeful that when you draw that reference triangle, you will recognize that it is a very familiar triangle. And you don't even need a calculator to figure out your answer to this one. I hope. Spoiler alert. What? Familiar? Nice. Those numbers sound really familiar to me. Do they look familiar to you? 1, 2, root 3. That's a 30, 60, 90, right? Which angle would be our reference angle? Is this the 30 or the 60? It's the 60, isn't it? Remember, the bigger angles across from the bigger side. Root 3 is bigger than 1. So this would be our 60. But that's not theta. Theta's not 60. 60 is our reference angle. What's theta? We could go negative 150. No, wait, that's not right. Negative 120. We could either go negative 120, or we could start here and do a positive 240. Awesome. Don't you just love how it just keeps coming back? Reference triangles, reference triangles, reference triangles. If Precalculus B had a subtitle, it would be reference triangles. Bless you. All right. How about a couple more? Let's convert some equations. You guys are going to love these. This is everybody's favorite, which means that it's not actually. That's okay. You guys got this. This is where we're going to get to practice with completing the square. Woohoo! Okay. So here's the deal. When we put these into polar equations, we're going to do our best to get them as functions, meaning we want an equation that says r equals. But in some cases, that's not going to be possible. At the very least, though, we want to eliminate any parentheses that we're dealing with. Okay, so we want to simplify to that extent. So A is a pretty simple one. What we need to be looking right now, and if you have a separate piece of paper, would be these equations right here. This is what's going to help us do some substitution. So if we can get something to say, well, if we can get an x or a y, we can replace it with r cosine theta or r sine theta. If we have an r squared, we can replace it with an x squared plus y squared, or vice versa. So what I'm seeing here is y equals 3. And I know that y is equal to r sine theta. So that would be my first step, would be to replace y with r sine theta. And again, if you can get it into a function in terms of theta, so a function of r in terms of theta, in other words, get r by itself, then go ahead and do it. Could you do that? Could you make this say r equals something? What would it say? R equals, how would you get rid of this sine theta? We could divide by sine theta on both sides, right? So we'd end up with 3 over sine theta. Yeah, that's good. R equals 3 over sine theta. Oh, I think that's great. Yeah. Oh, not for the whole class. No, but we got, but that's good for that equation. I think that's great. In fact, let me go into my polar equation here and just type it in and make sure. R equals 3 sine theta. You don't need to type yours in. I've got you covered here. 3 sine theta. Uh-oh, something went wrong. Oh, I know what went wrong. I'm still in degree mode. Switch back into radian mode here. There we go. Why does that make me happy? It's the same as the graph of y equals 3, isn't it? It's a horizontal line crossing the y-axis at 3. Cool. All right. What should this look like? We talked about this the other day. That's the equation of a, you didn't learn this in algebra 2, but I gave you a little shortcut on it. No, that's the equation of a circle. That's the equation of a circle. Go ahead and write this down, because this is something that's going to come up in calculus. And although you didn't learn it last year in algebra 2, you will need to learn it at some point. It's the equation of a circle. Anybody want to guess where the center is? I'll tell you, it has to do with these numbers right here. And it's not 1 comma negative 3. It's negative 1 comma positive 3. And its radius is, anybody know that? It's not 9. Notice everything over here is squared. Well, this is squared too. What's its radius? 3. So it's a circle centered at negative 1 comma 3 with a radius of 3. Now, I could start off by replacing this x with r cosine theta and replacing this y with r sine theta. But then I'm going to have to do the squaring, because remember I said you can't have any parentheses in your final answer. I'm going to have to do the squaring with that r cosine theta and this r sine theta. And doesn't that sound kind of messy? So what if instead we did the squaring before we replaced these things? You see what I'm saying? That would be a little bit easier. We've already talked about this multiple times this year. I'm hoping that you remember. Do you remember the shortcut for squaring a binomial? Do you know how to turn x plus 1 quantity squared into x squared plus 2x plus 1? Do you guys remember how to do that? That is a non-negotiable skill that you need to have when you walk through the door of your next math class, period. Okay, this is a squared plus 2ab plus b squared, right? You remember that? Can we do that here as well? What's this one going to end up being? Y squared, it's going to be minus, it would be 2 times 3 times y, which would be 6y plus 9 equals 9. Ooh, I like that. Yeah, it does. Yeah. Well, if you think about it, if its center is at -1, 3 and its radius is 3, then it is going to go through the origin, isn't it? Yeah. So can we agree that these guys are gone? It's a 0 now. That's cool. All right, let me rearrange this slightly to make it a little bit easier to do some substitution. X squared plus y squared plus 2x plus, oh, sorry, minus 6y. This is a little pro move that you guys are going to get good at once you've seen it once. Why in the world would I do that? Look back at the equations that I gave you for converting. I'm hoping you'll see why I did that. What is x squared plus y squared? It's r squared. You see why I put those together? Yeah, look at that, r squared. Hey, plus, okay, we're gonna have to use, for x, we're gonna have to use r cosine. That's okay. And I'm not seeing an easy way for me to get r by itself in this equation, so we'll call that good. There's no more parentheses, so we'll call it good. It's all r's and thetas. There's no more x's and y's. Any questions on that one? So you're gonna run into some of these where it's gonna have like some x's and y's in parentheses squared. My hint to you is do your squaring before you convert into r's and thetas, and try and get an x squared and a y squared together. If you can get an x squared and a y squared together, that's r squared. Cool, 2 more and then we're done. Yes. X squared plus y squared is r squared. We wrote that way back at the beginning right here, converting. R squared equals x squared plus y squared. It's also the Pythagorean theorem, right? It's, you could think of r as the magnitude, so the magnitude squared would equal x squared plus y squared. Yep, cool. All right, polar to rectangular, these are a little bit more straightforward. For these, we want to get them into a format where we've got, well, we want to either get r cosine theta or r sine theta, or we want an r squared. Ultimately, that's what we want to try and get, because those are the things that we have to substitute in for. So it's a couple ways we could tackle this one. I'll show you how I'd start. I would probably start by changing this cosecant into something else. what could I change cosecant into? 5 times 1 over sine theta, right? We're familiar with that. So 5 over sine theta. Man, I really wish that the sine theta and the r were on the same side of the equation being multiplied by each other. Oh, why don't we multiply both sides by sine and then we'd have that, right? That would cancel here and we would have r sine theta equal to 5. So y equals 5 and we're done. Because r sine theta, that is y, isn't it? Cool. That one was easy. I hope the next one's long and complicated. I do like these. Yeah, I like these. I like these. I like the messy ones. The messy ones are awesome. All right. So I'm going to tell you for this one, for part D, that the answer is going to be in the form of a circle. And I want you to write me the equation in a form of a circle. So the form of a circle is parenthesis x minus h squared, parentheses y minus k squared equals r squared. And I would love for you to write me your final answer in that format. And we're totally going to be able to, because we know how to do completing the square. Spoiler alert, we'll be using completing the square. You're going to love it. We got this easy stuff. All right, are we ready? Let me write this equation down again. R equal, I'm leaving a little space in front of it. 2 cosine theta plus 6 sine theta. So I know from experience when I'm trying to do this, these r's that are by themselves become problematic. We don't like these. We don't like them because when an r is by itself, you can't replace it with anything. You can replace an r squared with x squared plus y squared, but you can't replace an r with anything. Now in this problem, we fixed that problem by figuring out that we could multiply on both sides and turn that r into an r sine theta, and that could convert. This, we don't have that luxury this time. There's no way I can take one of these things and move it over and not have to deal with the other. So what other options do we potentially have? Yes. What if we multiply both sides by r? What will we get if we feel like we would get r squared, which is good. I like r squared. And here we would get 2r cosine theta. Ooh, that makes me happy. I know what r cosine theta is. That's just x, isn't it? And here I would get 6r sine theta. So your instinct, your intuition led us to a pretty good spot. I like where we're at right here. Because r squared we can replace. We've got on our conversion equations, r squared is x squared plus y squared. R cosine theta is just x, and r sine theta is just y. Hey, I don't know why I wrote 2. That should be a 6. How are we feeling so far? We are going to have to complete this course in the next step. So some strategies you can use. You're going to run into one problem on your homework where instead you'll square both sides of the equation, and that'll get you an r squared. That wouldn't have worked too well for us here, though, because this would have been pretty messy if we tried to square it. Right. So either multiply through by r, square both sides to get an r squared. Sometimes it just kind of comes out in the wash if you multiply both sides. Okay. So let me give you the next step, and then from there, I'm hoping you can tell me where to go. So here's going to be what my next step looks like. X squared minus 2x plus blank plus y squared minus 6x plus blank equals 0 plus blank plus blank. Disregarding all the blanks, are you okay with how I got basically just got a 0 on one side of the equation? And then I put some blanks in there, and I put the blanks in there because that's what we do when we're completing the square. Yeah, so I'm going to put a number in this blank, and I'll put the same number over here so that we keep the equation balanced. And I'll put a number in this blank and the same thing over here. So all I need to do is remember, how do I take this middle number and turn it into a completing the square? What should it be? Should be minus 6y. Thank you. Thank you. Thank you. Do y'all remember how to complete the square? Divide by 2 and square it. So -2 divided by 2 is -1. And square that, you get +1. That's going to go in that blank and that blank there. Because remember, we got to keep it balanced. Can't be adding something on one side and not on the other. And here I'll be looking at this -6. Cut it in half. Divide by 2 gives me -3. Square it gives me 9. Put a 9 over here too. Keep it balanced. Oh, we are so close, folks. Now we can factor it. Something squared plus something squared equals, that's just a 10 over there. Tell me, what do I have in this first parenthesis? X minus 1. And y minus 3. And we're done. It would equal 10. But if I asked you what the radius of that circle was, you would tell me square root of 10. Yes. And it's centered at what point? -1 or +1 comma +3 with a square root of 10, radius is square root of 10, which is a little bit bigger than 3. Agreed? Hey, let's type in this equation and see if it matches. I'm going to put it into my, I'm already set up in polar mode. You don't have to type it in if you don't want to, but I'm just curious. It should be a circle centered at 1 comma 3 with a radius of whatever the square root of 10 is. So I'm going to go, original equation was 2 cosine theta plus 6 sine theta. Fingers crossed here. Hey, it looks like a circle, doesn't it? Does it look like it might be centered at 1 comma 3? Yeah, totally. And a radius of a little bit bigger than 3. Yeah, it matches. Woo, we got it. All right. So that gives us a big old chunk of time to start on our assignment. If you've got individual questions over anything that we went over today, just get my attention. I'll be around. I recommend that you have your wheel of fun out. You know what I mean by wheel of fun, this thing. And why don't we take a look at this assignment together and see if there's anything tricky I can give you some hints about. See what we're doing in here. It looks like a lot, but I bet it's not. $539. All right, we're doing 15 to 18. Oh man, kind of mean, Mr. Height. 15 to 18. Instructions are find the rectangular points if you have the polar points. Oh, that's easy. That's like way too easy. Although I do notice that some of the angles are weird angles that we haven't dealt with before. -29 pi over 7. So when I get to number 17, I can't really use my wheel of fun for this. So what am I going to use instead? Calculator. Now, number 15, number 16, we should be able to do those with exact values. But 17, 18, yeah, 14 pi over 5, that's not an angle, that's on an angle on our unit circle. So 17, 18, all 29 to 34, all, what? All right, 29 and 30 are the same. They give you rectangular points, and then they want you to come up with, polar coordinates. Now look at this. they're going to ask you to come up with 3 different versions of polar coordinates. Remember how we talked about there's like an infinite number of ways to name polar coordinates? They're going to ask you to come up with one between 0 and 2 pi. They want you to come up with one from negative pi to positive pi. I have a feeling that in some of these, you're going to need to use a negative r to make it work. And then all polar coordinates from 0 to 4 pi. Oh no, sorry, I misread that. They want you to come up with all of the different polar coordinates that satisfy this. So for 29 part A, I believe you are going to have two different versions. One of them is going to have a positive r and one's going to have a negative r. Same thing for part B. For part C, I think you're going to have 4 different versions. 2 that have positive r's and 2 that have negative r's. You can do it. You can do it. There's only 2 of those. 31 to 34. Oh, you guys love these ones. There's no work to do for these. I'm serious. There's no work to do. You just type the equation in and tell me which of those 3 graphs it looks like. That's kind of what we were doing, messing around with on Thursday. So that's easy. What else did I give you? 35 to 49 on. Oh my gosh, that is so many. All right, 35. Let's look at this. Oh, convert a polar equation to a rectangular one. And then it says support by graphing. So just graph it in your polar and make sure it matches up to your rectangular. Yep, those all look very familiar, very similar to problems that we did. And then 43 to 40, how high up are we going? 49 is the opposite, same deal. It looks like you're gonna have 2 that are gonna be kind of the messy versions. 47 and 49. I think if you're taking notes here, 41 is the only one where you'll have to do completing the square. 47 and 49, that's kind of like on the last set of examples that we did. Remember where I told you to go ahead and square it while it's in XY form before you convert? That's where you want to do that first. Those won't be too bad. And then 51 is a word problem. So very doable. You guys have how much time here? 20 minutes? I bet you get halfway done with that in 20 minutes if you get after it right now. So let me know if you have questions on anything we went over today. And I'll be around to, I think all I need to check, unless you were absent on Thursday, all I need to check are your polar graphs. If you're absent on Thursday, I'd also like to see the projectile motion problem. Let me check in just a moment here.